Welcome to this Zoom webinar for March 19th, 2021. This was done from an office at American Beverage Depot in Miami, Florida, and I was talking to Juan Pablo Garbin, one of the principals of American Beverage Depot. Hope you enjoy it. My name is Frank Lamb, and this is an Automation Academy Mastering the Machine webinar. We do these every 2 weeks. And the Automation Academy is a kind of a subdomain of my main website, which is a business website. And I kind of added this and created a group within it, the Automation Academy, and some of the people in that group that have joined gave me some feedback and said, you know, you got a lot of nice PLC classes and things like that on here, but gee, we'd like to learn more about systems integration. So I had a document, this document called Mastering the Machine, and it's been my lead magnet for a long time. People download it and they read about it. And it's mostly about how do machine builders quote machines. And it talks more about the documentation and things, but I decided to name this webinar about systems integration after that Mastering the Machine document. So that's kind of where all this came from. And of course, I encourage people to join the Automation Academy. We've had several new people join lately. It's been kind of fun. But this particular webinar, instead of doing it from my office, I am doing it from Miami, Florida. And in Miami, there is a company called American Beverage Depot that I've been doing business with since about 2013, I think was the first time I came down here. One of the dilemmas when you're in systems integration is people call you in to work on a specific thing and you haven't seen the thing yet, right? So in this case, I came down here and it was a Slick 505. Some of you may know what that is. Some may not. It's an Allen Bradley PLC, but it had a DeviceNet card on it. The DeviceNet card was connected to a whole lot of little remote devices out in the syrup room. And I may actually have a good picture of the syrup room. Yeah, this thing. So this is a part of the syrup room. And you can't really see them, but you see all these sensors here. These sensors are connected to little boxes that were back on the wall back here. And those devices, they're DeviceNet. And DeviceNet is an idea that Allen Bradley had that was worse than many of their other ideas. What DeviceNet is it is a remote I/O method, and it's very difficult to configure. One, because you have to have, as with all Allen Bradley projects, you have to have another set of software. So Allen Bradley is very good at the PLC part of things. They're not very good at communications. As a matter of fact, I think they're the worst at communications. They may have the best software, but they have the worst communication software. So you already have this thing called RS links that you need to go talk to things. But with DeviceNet, you also have to have something called RS networks to configure your network. So back in the day, which I would call the 1990s or so and before, they didn't have Ethernet IP. They had regular Ethernet, right? You could use TCP/IP, and the World Wide Web was just starting to grow and things. But to communicate to your PLC, use TCP/IP and drilled into the PLC, but you could not do I/O at that time with Ethernet. One thing is that regular TCP/IP is not what they call deterministic, which means it tries to communicate, and if for some reason it can't communicate with the device, it just tries again after a random period of time. So it goes to the IP address and just tries until it can communicate. And if it can't communicate, you see the little hourglass sometimes that pops up. If it can't communicate, eventually it hangs up, right? So it'll try X number of retries and then it'll hang up. Well, you wouldn't want your I/O working on that basis. So Allen Bradley, in their infinite wisdom, they already had something called remote I/O that worked pretty well. It used a remote I/O protocol, and you would put a little remote scanner in there and hang devices out remote I/O, but you couldn't talk to smart devices. You could only talk to Allen Bradley specific little cards and things like that. So they came out with this new concept, DeviceNet, and DeviceNet was meant to talk to smart devices also, kind of like HART protocol and things like that, but even smarter. So you could get diagnostics from your instruments and things like that. Well, when I first came here, these little boxes were hanging on the wall back here. And of course, you could get diagnostics. You could tell whether the little box was good. And if you had a smart sensor plugged into that box, you could also tell whether your device was, healthy. But the problem was, once again, you had to get RS networks. You had to tell it what all the nodes were and everything. And if you brought up your PLC program, so I'm going to bring up a PLC program from now. Let's see how this looks. So we're on a virtual machine here. Phil, can you see this? You can see this software here?
Yeah, I can see the RS Logic software.
Okay, so I popped the other one up, and this is kind of now how it's done. So if I look at my Ethernet tree here, right, I can see the devices on my Ethernet tree. I could always see these kind of things, cards and things like that, but I couldn't see my network. So as an example, I'm going to bring up another one that I happen to have open here, which is the same line that I showed you that picture of, right? The picture was of those tanks in that room. And this DeviceNet card was on a SLIC 505. And a couple other things about that SLIC. One, it was pretty full. It had a really long scan time, and it was pretty much close to its max, right? So when we decided to expand that area, we couldn't even use the 505. We basically maxed it out. We had to add other things to it. But in any case, so you see the DeviceNet network, but you notice there's no devices on it. That's because you need that RS networks, which really sucks. So you just couldn't visualize the whole thing. Now, let's contrast that to Ethernet IP, and you see all the stuff on the Ethernet tree, right? I see a ton of stuff there. And I can drill down into that and maybe like this, double click it, and I can see the configuration, and I can see the health of the module while I'm not online. We'll try going online just for fun. So anyway, you can see this is kind of better because I can see everything on there, and I can drill down to it and double click it and talk to it. So you couldn't do that with DeviceNet. Couldn't see everything. So now I'm online. You see the health of it. This one happens to be unconnected. This is one we just added, by the way. So we will be connecting to this today. But so I'm kind of wandering here, but here's another dilemma. This is another one of those systems integrator dilemmas. We put this thing in, hung it on the wall, I'd say day before yesterday. At the time, this syrup system was not running, so I could do a download. Well, there are some things that you can configure online, and there are some things that you can't. All right, so we added this, and I set the address to it, and I can see it, right? I can see whether it exists, but it says configured but not owned. Well, to own it, one of the things I have to do is I have to go in here, and I have to change this revision. It's the wrong revision. So this is one of those things. You come in here and you see that it was configured as a 3. That was what was written on the little label on the side. But when I go look at the module itself, I see that it's a 2.003. For me to change that, I have to go offline, change it, and do a download. If I do a download, everything stops. Not good, right? I'm in the process of running this thing, and in this case, big tank farm. So we'll go back to the tank farm here. There we go. It's this thing. So right now we're filling these tanks, and these tanks hold about 9,000 gallons apiece, and they slowly drain into these things called the fillers. I'll show you a filler. If I can find a filler. This is kind of the outside of the filler room. Hard to see, but the fillers are actually through the window in here, and I do have some other pictures, but in any case, so let me go back to that first visit. So that first visit, I came here into these tanks. I fixed this. At that time, they didn't really have a lot of guys that could go online even with a PLC. maybe they could do some basic stuff, but they also didn't have like a full copy of the program, commented and things like that. Back to the history a little bit of ABD, and my history with ABD, right, has its roots in the Argentinian traditional bottling industry, and the facility opened in September 2004 as a new facility. When they did that, they used pretty standard equipment from very famous companies called Seidel and Tetra Pak. And Seidel and Tetra Pak manufacture bottling equipment and box making equipment, like you had those juice boxes and things like that. And so they put a lot of that in back then. Now, since then, they put a lot of other stuff in there and done their own expansions. But one of the things about Seidel especially is they own those programs and you can't change them. You can, right? But for instance, if you break something, you'll have to call them up and they'll come out. And some of the stories I've heard from here, Juan can tell you a little more about that later, but they'll send somebody, for instance, from maybe Atlanta or even Italy to take a look at the machine because it's down and it's broken and we need to fix it. And they'll charge you from the minute they leave their house and get on the plane and fly over here. And by the time you're done, it may be the wrong guy, right? So the guy who came out may be the mechanical guy. And he says, okay, well, all the mechanical stuff looks good, but you have a problem, for instance, in your Profibus. And I can get on the phone with somebody in Italy, but I can't fix Profibus, right? I don't know the controls in. So then maybe he goes home or he gets on the phone and maybe that guy has to come in. So by the time you're done, you're paying a lot of money for service. And I'm sure they would sell you a service contract also, but that's a whole different thing. I know of a company in my area, for instance, a guy named Jason Lefevre, he's a member at the Automation Academy. He says that Dematic, which is their storage and retrieval system company, charges them $23,000 a month to just be able to look at the machinery, not to fix it or anything else, but if you have a question, you call them up and they will, they'll help you solve your problem by going online, but it's $23,000 a month. Seidel may sell you the same thing. But I think Juan Pablo told me one time, $20,000 would be a typical visit from a mechanical service guy, just to get him on the plane and have him come out here and spend some time in the plant and try to figure out what's wrong. So it's in their interest anyway to get things under their control, right? So when we started this, the way Juan Pablo and I met, I was introduced to Juan Pablo by Mike Henry from a company that I teach for. And it says here 2014, so I guess that's probably when it happened. I started teaching for them in 2013. And Mike Henry, Juan Pablo asked Mike Henry, can you come out and work on our machines? We have some Siemens and we have some problems with the Siemens. Can you come out and help us? And he said, well, I live in Canada and I work full-time for automation training. So probably can't help you, but we got a new guy down in Nashville that's teaching for us now. Maybe he can come out and help you. So Juan Pablo called me and I came down here. And this is that first trip, made several program changes to the syrup lines, Slick 505 with DeviceNet. Now, I don't know how much you guys know about the Slicks, but anyway, old PLC, old communication protocol, old networking thing. I don't wish this on my worst enemy. It still exists, but don't use it. Even though they have scanners for this, for the control logics, the better choice by far is Ethernet IP, right? Even Profibus would be better than this, which is not even an Allen Bradley thing. Go get Profibus from Siemens, put a Profibus card from ProSoft in there, and it will work better than DeviceNet. Just avoid DeviceNet. For one thing, you have $1,000+ software package you have to buy with it, plus the devices. But the good thing about DeviceNet is other companies make devices for DeviceNet. They did not make devices for remote I/O. So you couldn't get that smart information out of a device on remote I/O at all. I couldn't see the health of an SMC valve bank or a Festo valve bank or something like that, or a camera. That would be a typical thing you'd like to be able to add. When DeviceNet came out, all of a sudden, I get smart information from my sensors, and I can put these little blocks out there. But as I said, the downside is you go buy RS Networks, which they did, right? They have RS Networks here now. If they need it, they can use it. They had an RS-View32 SCADA interface. This again now, for those of you, I think everybody knows what SCADA is, hopefully here. What that is, when they say supervisory control and data acquisition, all this really was a fancy HMI more than anything. But it did recipe formulations and things. So it had some pretty good stuff in it, much of which Juan Pablo, who's sitting behind me here, modified and changed, right? So he learned something about RS-View32, but then migrated to Ignition. And that's what we're going to kind of talk some about today, because Juan Pablo is way ahead of me on the Ignition side. So we're going to talk a little bit about what that does. Anyway, I came here for 2 weeks. Then I made another trip in October that year. So this was August. Oh, by the way, it was really hot, really sweaty. I crawled around under the machines and I was looking at these devices and resetting some flow transmitters and things, and it was sweaty, and I was not having a good time. It was just hot and miserable, and there's even mosquitoes and things like that, but so be it. So that was my first trip. Then I made a second trip. Hey, it's October. It's a little better, a little cooler. December, a little cooler, 2 more weeks. So one of the things that happened for those of you getting into systems integration is over these trips, I'm drilling into the program constantly, and I'm learning how the program runs, right? Which is a Slick 505 program. This is an older Allen Bradley system. I believe Tetra Pak. It wasn't even, let me ask Juan Pablo, do you remember who was the people who wrote the first Slick program?
Tetra Laval, which was a part of before Tetra Pak and Seidel were one company, and Tetra Laval was the process.
Okay.
So
you're going to log on in a minute here.
I'm trying to have a microphone. If you have another one.
Another microphone?
Yeah.
I do.
Or,
I have another microphone.
I don't want to do the echo. No.
I have a microphone.
Okay, let me talk with Fred because I can do PLCs, but I cannot connect a Bluetooth.
Okay, he's trying to get online, so he'll be on here in a second. But in any case, yeah, so he said it was called Tetra Naval. Anyway, this was a pretty new plant, and when they came from Argentina, they brought Brazilian Seidel in to put all their equipment in, right? So this was a lot of the commenting in the program is in Portuguese, which was interesting. Now, of course, Juan Pablo speaks Spanish. He's from Argentina. Portuguese and Spanish are close. Looks like Jose is on here. He might be able to tell me how close they are. Not close enough that I understand it, right? And I don't understand much Spanish. I'm not particularly good at it. But in any case, I'm dealing with that kind of program. Then they asked me in 2015, they said, we'd like to put some new tanks in here. So you saw the tanks that were on here. We want to go from 4 tanks to 7 tanks. And I said, well, if you're going to do that, I personally hate DeviceNet, so I would rather go to something else. And they said, okay, well, what do you suggest? And I suggested Ethernet IP. And I said, the problem is Slicks don't do Ethernet IP. So we had to migrate to something else. And while we were doing this, there's a kind of a fun picture in here. If I can find it. Ta-da. Yeah, here we go. So I started dealing with Luis. Luis is the plant manager here, and Luis is a mechanical engineer. So Luis knew how to connect all the piping, right, and figure out how are we going to get these new tanks in here. When you bring in new tanks, you have to basically do this, okay? So to run the new tanks, you have to connect maybe the new tank to a certain line. You have to go and get ready to run all that stuff. So you got to move these things around. There are sensors on here that detect whether the piping is in the correct configuration. And so he drew all this, even though Luis is actually pretty good at CAD, has done it for a long time. He took pieces of paper and tied them together. And I think you can even see a remnant of this maybe behind me on this wall down here. There's a map of the plant, and there's Juan Pablo. All right. So there's a map of the plant down here, and he hand drew all this. And this drawing was probably 6 feet across by something hand drawn. My method, I didn't want to mess with his drawings and everything or fix things. So what I did is I took this picture, right, which I had access to all the RS-232 or the RS-View 32, which was the SCADA system, and I drew the new tanks. And I drew the interconnection for the new tanks. And so I used this drawing to communicate back with Luis, who was using this drawing, which was kind of interesting, right? We exchanged information that way, even though we both know CAD, but at the time, I think I had CAD installed on a different computer or whatever. So that was our first little adventure there. We added all those tanks, syrup line, design programming for new tanks, design startup for new tanks by May of that year, June startup. I taught a class in Orlando at the same time in June and August. So what I did is I teach the class, then I'd come down here from Orlando. I'd drive to Orlando, then drive to Miami from Orlando. So I got in the habit of driving to Miami a lot. Poseidon Work, that's another customer I have in Florida, same thing. Did startup a week here, and then I did some Poseidon work. And you see how long this takes. So startup for new tanks, 1 week PLC class for maintenance. Oh, this was a class that we held here for maintenance, and this was interesting. Juan's here, so he remembers this. He brought his guys into the class, and many of them don't speak a lot of English. Some do, some don't. So Juan also interpreted. During this time, Juan first got into PLCs in about 2014 and took the class from Mike Henry. And then every time I'd come out here, you know, he'd be learning stuff, and you know, I'd be learning stuff about the system. So we kind of grew together on this stuff. Then, so where it says here, filler syrup data, this is where it got interesting. Somewhere in this period, there's a gap where Juan installed Ignition. And he decided, okay, instead of using RS-View 32, and there's some history behind this, he said, one, RS-View 32 won't do some of the things I wanted. He had gone and got a Visual Basic guy to do some code for him before I think I ever met him. And he didn't, you know, the guy did some work, but every time he wanted to change, he'd either say, well, I can't make the change now, or you make the change, or I don't know what all happened. But anyway, Juan really wanted to be able to do some of this work himself. So he said, well, if I buy Ignition to put it in here, I can do things like some of these other recipes and maybe invoicing or play with barcode readers or do a lot of things that RS-View 32 wouldn't do. So we did a kind of a couple things here that were interesting. We migrated the SLC 505 and put a Compact Logix, which is a new around Bradley PLC, to do the Ethernet IP. And we exchanged information between those two PLCs. We messaged back and forth and grabbed the information from the SLC and slowly migrated to where now the SLC's not there anymore. So we upgraded from the Compact Logix and put a Control Logix. It's an L63 processor in there. And now almost everything is Ethernet IP, except for like there was one valve bank. So all the little remote blocks now that I had so much trouble with DeviceNet are now Phoenix blocks, and they're Ethernet IP, and they're real easy. You can drill down to them and see what the problem might be with it, right? And if it's bad, you just throw it away and get a new one, and put a new one in there, or switch inputs or whatever you need to do. So during this time, Juan Pablo's putting Ignition in here, and he's starting to do some really interesting things not connected with just regular recipe selection and things. And I'm going to kind of let Juan explain a little bit of what he did in Ignition, because he's migrated now to where he creates reports that are production reports. He has people doing some things manually that we hope to do automatically. So for instance, when a pallet finishes on a palletizer, the operator goes and he scans it and he prints a label and sticks the label on the pallet, and then the pallet goes into the warehouse and they track all that. Ideally, we want all that to be automated, and the little hooks for that are all in Ignition, but making it work is the tough part. And so now Juan's been doing this since, I don't know, 2016 16, you're there, right? You can go ahead and unmute. I can't hear you. Go ahead and hit your unmute.
Okay. Yeah, I've been doing this since 2016, actually. Yes, 2020. I got their trial in 2016, and I actually bought the program at the beginning of 2017. The main reason actually to switch to Ignition was the fact that we, like Frank said, we hire a guy to do part of the shipping and production, and we run into some problems, and like most of the people that you hire, they want to do things their way. And it's a matter, that's when I decided, if I want to switch to something that I can either maybe sell later, or even like scale up if I want, or because we have also another company in Argentina. We have a winery in Argentina that I want to redo the project that I'm doing here over there. And in those type of projects, you end up paying twice as much for the money, plus you don't know what they did. Usually their code is protected, and well, you know me, Frank, I want to know everything, so I like to do. So when I started with them, we first switched the syrup, because it was like my start of my playground. And then we switched the syrup room from the RS View to the Ignition. And the main goal is to do everything from the receiving, that the actual finish line would be the people receiving would scan the product, they go inside all by by digital, no more paper. And then the actual product line, like you said, at the end, the palletizer would, the idea would be if the pallet has the correct cases as it is scheduled, then the printer would print the label and apply the label to the pallet. Removing the operator that unfortunately humans will make a lot of mistakes. So, for example, one of the mistakes right now is when we switch lots. When we're switching a batch to a new product, we do mostly juices here. So when the people here, they switch to a new lot, sometimes the operator at the end of the line, either they switch too early to the new lot when they print the pallet, or like the other day, they printed 30 pallets with the same lot, and the maximum that we can do in a lot is 13. So we had to go back and change the lot. So it's something that we're trying to little by little right now, until we have a machine that does it by itself. The idea is to protect the mistakes. So now we're gonna do. Frank did a big part on the PLC that actually closes the batch by itself whenever they switch to a new tank. And with Ignition, the easy part is usually connecting from PLC to SQL. And so what we're gonna do is, whenever the batch ends on the PLC, it's gonna let the operator know at the end of the line that the batch is finished, and it's only going to let them do one more pallet. Because from the time that the tank finish, usually we have one more pallet of finished product until the end of the line. So ideally, they could be able to do 2 pallets if they want, but like a warning would appear. The lot has finished. Do you really want to print another pallet with this lot number, or you want to switch to a new one? That way, and until we get a machine to not make mistakes, humans would make less mistakes. So that's basically the idea of making the whole product line. And at the moment, we only knew Ignition. Now this week we've been looking at other softwares, but the problem is always when you are comfortable with something, you don't want to switch to something you don't know. But it's like everything, we need to change to be better anyway. So okay, so well, we were going to talk also today that we wanted to talk with Frank was also some part of networking. We've been trying to do. We have many machines on the plant, and each machine is designed. Okay, good. So each machine has its own PLC, and some of the machines have multiple slaves that are also on Ethernet IP that are on a different network. For example, we have a palletizer that we've been dealing the last 5 days actually, and it's the palletizer is on a subnet that is completely different than my Ignition PLCs, and we also want them to keep separate so that we don't have traffic. We figured out a way of putting a small router in front. So let's see if I have it here. So the basic idea would be to go straight from our main router. We're gonna put like a small little router before the palletizer, and we're gonna go through the one network, which this will be the plant network, and we will come out with a different IP so that we can see the palletizer, but the palletizer cannot see anybody else. That way we provide, security for the machine, and the only way to access the machine would be through the router, that it would be through the firewall. The main reason for doing this is we like to work remotely a lot with Frank. Sometimes I go to his office and he comes here, or I work from home, or right now I want to take a big vacation and I want to be able to not have to fly back if they have a problem. Plus, it also adds the reason that we can get data from each machine in real time. That's our, once we finish the shipping and receiving, what we want to do with Frank is an OEE that we started, little by little, but it's a project that usually is done by the team of engineers, and right now we're only two, so it's taking time. But the main idea is that to have all the plant networks, like he's showing on the screen, that's our, Ethernet network that we have, and the idea is to put every single machine on the plant in the network, and we can access either through the internet of the plant, or also remotely through a firewall that we will be protected.
So what you see on the screen here, a lot of this, right? We've been collecting these IP addresses. There's quite a few of them on the plant network for quite a while. And the syrup, where we had all those remote devices, these are all in this 58 subnet here. But the main data collection of the plant is in the 57 subnet. So one of the little dilemmas we had that Juan was talking about is when we added the palletizer, we know its address, but we can't change these addresses. They're from top tier. And it's not that you can't, but if you did, one of the things you would be doing is you'd be putting all these things on the data collection network. We wouldn't have any choice because this thing only has one Ethernet port, right? And right now it's set to 2150. And the other dilemma we have is that everything top tier sends out is all at 2150. Well, you can't put two 2150s on the network, right? And they all have these drives and things. They configure everything the same way. So we started looking into how do we talk to two things on the same network. And we talked to, for instance, RTA. Don't know if you've ever heard of real-time automation, but they make protocol converters and network isolators and things like that. They're pretty cool. ProSoft is another famous one. But what you can do there is you could, for instance, convert Ethernet IP to Profinet, right? So go in one side on Ethernet IP, come out on Profinet. It does not change the address, however. And so we asked them, I actually got on the phone with him the other day. I said, do you have something that would do that? Could I go in on one address and come out on another? And then we started looking online, and you go to like PLC Talk and Mr. PLC, and there's a bunch of guys on there that give advice. And we found some pretty cool things. Let me see if I can find the drawing for it. No, I don't think that's it either. Well, here's one picture that I found, right, of people drilling in on different networks with routers and then putting things on the back side. So one of the things we looked at doing, and now I can't find my drawing, but there was a guy who asked a question on PLC Talk and said, can I basically use port forwarding to go in on one side and just automatically forward this to this port and not care what's on the other side? In other words, put this 150 here and then put another 150 on a different port and address it by port instead of addressing it by Ethernet address. Well, hypothetically, I think you could do that. You could just route traffic through a port. But unfortunately, one of the things Juan discovered last night at 10:30, I think he sent me the picture, is that Alan Bradley communications, for one thing, Juan knows more about like what port you have to open. There's like what was the numbers, Juan? One was
to connect remotely is port 44818,
Yep.
and then port also 2222.
Yeah, so 44818 and 2222. And they're not the same ports that you would use with a regular computer, right? So Allen Bradley really cares about its communications. And I would think, you know, especially with all the security protocols, and you don't want people hacking into your plant and all this, they have some kind of rules. Certain ports have to be opened. You have to put the gateway, in any case, in the hardware configuration of the PLC, which means we couldn't really do that. We can't just anonymously forward something through a port and say, hey, whatever's connected to it, we want to send it to that. Well, the other issue is on the same network, we're kind of stuck because this only has one port, and you have all these other devices, the HMI, all the drives, they're all on the same network. They have to be on the same network. So you wouldn't be able to target just the PLC anyway, right? So what we've come up with now, and Juan Pablo's got it working, is just putting a router with like an address on it, and then on the backside they can be the same address. Now, when we did that, I just made this little map this morning because all we had was kind of this. But when you look at it in a different way, you realize, okay, like these three guys here, those are on the plant network, and these are Ethernet IP devices. Ethernet IP devices, see if I can find this again. Ethernet IP devices have what's called an RPI. So an RPI, you are telling it how often do I want an information update? 20 milliseconds, okay? That's the default for discrete stuff. Sometimes analog stuff, maybe 100 milliseconds. Well, the problem is you're doing data collection. If you had all your stuff on there, like back to Ethernet again, if you had all these on the network and they were all reporting, right, every 20 milliseconds, you can imagine the traffic that you would have. So on the ignition side, here's the ignition SCADA system. One can say, how often do I want to pick up this information, right, from this specific place? So he goes and he kind of polls different things. Like we have the syrup PLC. We also have another PLC I don't see on here. It is the data collection PLC, and it's somewhere down in here. Card slot 6. It's sitting in another room, and we honestly haven't been using it a lot. But what we do there is we use what's called produce consume tags, and they exchange information. I don't remember if it's on the 58 network or the 57 network. Hopefully the 58 network. I think so. Matter of fact, it's on the 57?
Data collection?
Yeah.
Yes, 57.
Okay, so that's not necessarily good because the data collection is every 20 milliseconds sending information to this PLC on the data collection network. But Juan Pablo needs to be able to get the data collection information. So one of the issues we've got, there's a kind of a map of this plant in here. See if I can find anything. But anyway, the way the flow goes is it goes from the tanks into the pasteurizers, which have a little PLC, and then from the pasteurizers, it gets routed via those flow pipes to one of several fillers. Well, you want to be able to follow production, ideally, from a specific tank, from a specific batch. You made a specific lot of juice. You want to see which pasteurizer did it go through, because, for instance, there's a chart recorder on the pasteurizers, and we know, hey, this has been approved, right? There's a guy that comes and looks at those pieces of paper and says, your temperature was up to temperature the whole time that it ran, right? So that's kind of quality control. Then it goes into a filler, and depending on where the pipes are, that's what chooses the filler. Coming out of the filler, it goes through, various packaging things, but we want to know production for all the various packaging things. So we want to know how many little straws did you use that it sticks to the sides of the little boxes? How many cases of these boxes? Some of the little juice boxes go into cases. So we want to know production on how many cases, how many boxes, where did it come through? One of the dilemmas is when you switch tanks, and I don't have again, I wish I had a good map of it, but when you switch tanks, if you were using tank 1 and 2, and I switched over to tank 2, which was a different batch, right? All of a sudden, you just change the piping. Or you don't even change the piping, you just reroute that tank, and it follows the juice from tank 1 right through the same pipes. So I've got to kind of guess, when did that hit the pasteurizer? When did it hit the filler, right? There's a bunch of piping in between there, and you don't know the exact boundary line, but you do know, okay, this tank's done, and we switched over to this tank. Well, at the time that it's in the pasteurizer, that the juice from the first tank is still in the pasteurizer. The juice from the first tank is still in the filler, right? And then we switched over to the second tank. So when did the juice from the second tank get into it? There's really no way to track that exactly. You're taking a guess. You're just saying, okay, well, it takes 2 minutes to get from this tank to the juicer. So 2 minutes, I'm going to switch batches or whatever. So that's one of the reasons that we have this other PLC sitting there collecting data, and it's connected to a lot of, let's see here. Well, it's not connected to the compressor, but there are a whole bunch of things on the Tetra Pak line, cartoners and packers of different types. And then ultimately it goes to the palletizers at the end. So if you were to make this totally hands off, right, you would want to know the lot number for that juice, the batch number for the juice, which tank did it come from, which filler did it go through, which case erector did it go through, where did the inventory for those cases come from, right? When did you receive the cases that, or the film that wraps the pallet? You want to know everything about your process ideally. That's what Juan's working on. So he's got a giant SQL database, and he's collecting all of that, right? Right now, some of that's manual. Not manual exactly, but they'll scan a barcode in receiving, and that goes into some kind of a file. But how do you connect that file and automatically track everything used on that line, so that if I take a specific pallet, I can say the cardboard, right, came from this. The packages came from this box. It went through this filler at this time, so you know everything about it. Almost like you do in pharmaceutical. If you've ever dealt with pharmaceutical or medical devices, I had a webinar here with Carlos, and Carlos said everything has to be traceable. The package, the batch number, what pallet did it go on, what box did it go into, right? When was it made? You have to track everything. Well, that's what Juan Pablo wants to do with this whole system. Ideally, it's totally hands off. So for instance, the other day, we're sitting there on that palletizer working with the communications issue we have, and the operator, the guy who drives the fork truck, is coming up and he's going to the touch screen, and it's partially automated. He says print label, right? But that print label is not connected to the palletizer yet. So ideally, the palletizer would finish up. It would say, this is the label you need. The label would be waiting there for him. He'd just walk up and pick it up, and the palletizer would tell it to print the label. But the palletizer needs to know all the upstream information too, right? So that's why we're connecting all this. That's why all this stuff is networked. And there's obviously more. As a matter of fact, I don't think we have the Tetra devices on here.
No, not yet.
Not yet. Okay. So he's got other stuff. I'm not going to show all that. He's got things like cameras. He's got cameras all over this plant to be able to monitor everything. That's on a separate subnet, right? So he's got something here called CamNet, and I don't think it has necessarily any addresses or whatever on it, but there are a lot of other things here too. So this little map that I just started making this morning, and I don't choose Excel to present things as far as a big report, but the next step would be, can we make little pictures of the PLC, the control device, and for instance, the different networks? Like here, we've got 2 Ethernet cards in here. One's on a private network, one's on the public network. Theoretically, you can drill through the backplane and bridge from this network into this network. So that's kind of a nice thing. You can see all these devices and things like that if I get online with it. So ultimately down the road, as Juan Pablo mentioned, he's going on vacation in, I think, May, and he's leaving on an RV. And when he goes, he wants to be able to connect to every PLC in the plant, because like it or hate it, Juan is one of the principals of this company, right? He's one of the owners of the company, but he's the guy who is number one that they call if they have a PLC problem. They may have some guys around here that can go online with a PLC and do something very simple, but if it's anything very complicated or you need to trace things, the owner of the company has to get online with the PLC. That's pretty unusual, I would say, right? If you're in a big Coke plant or a manufacturing facility, usually the owner of the company is not the tech guy, right? But for whatever reason, that's kind of what this has turned into. So Juan's I asked him what his official title was the other day, because I know he owns a big piece of it and his sister owns a big piece of it. He says, I guess I'm the operations manager, right? Because there's a plant manager here and there's a maintenance manager here. But if it's technical, it's going to Juan or myself. Ultimately, we're the people who would go onto the PLC and probably change something. Although there's a couple guys here that could probably change a timer, change something fairly simple. But they're busy doing other things too. I mentioned the class that we had. Guillermo is the maintenance manager here, and Guillermo's a smart guy. But Guillermo, at one point, I think was working 7 days a week, 12 hours a day, 15 hours a day. I don't know. He's crazy. He likes to work, I guess, but he works all the time. He works on the weekends and everything else. So the last thing we want to do is add PLC programming to Guillermo's whatever. Guillermo has a bunch of maintenance guys working for him, and you don't want, them to call, hey, Guillermo, can you come out here and go online with this? He's the guy who physically goes in and removes like giant sections of the Tetra Pak machines, because he's the only one who knows everything about every machine. So he's the guy doing all the mechanical work. It's nice if he learned PLC programming, right? But I don't think he's the guy you want going out there and connecting to the PLCs in the middle of the night, because he's already working who knows how many hours. It's kind of crazy. So anything else, Juan? You have any comments on that?
Well, mainly the reason why I have to do all the PLC part, and actually it's actually a simple reason for me. It's that most of the mechanics that we have are specialized either on Seidel blowers or Tetra Pak machines, which is already a trait that is very valuable for any company, because there are not many that are very specified on those things. And when a mechanic learns, I mean, they're mechanics, and that they're like electricians, most of them, so they all know electricity very well. So if the two people that we taught a little PLC about, they left to other companies, and I cannot lose any more people. So the fact it's not a really easy situation, because it ties me to the problems of the company. But at the moment, losing somebody would be even worse. And it's not that we don't pay them enough. The problem is that when mechanical part and the programming part, you become a specific person that you can charge $60, $70 an hour, and they're not gonna have maybe a salary every week, but they can work like independent in another company, and they make the same. And I don't blame them. I would do the same if I was them. But I cannot lose any more people. So that's the fact that I'm the only one person that I would train that is Humberto. Humberto is a magician we have here, technically, because he fixes anything that is broken electronically. He's an electronic guy, so he can fix VFDs. He can fix anything that we break. I mean, we don't buy anything else electrical anymore. He just fixes them. So, but I know he's a person that wouldn't leave. He's very happy here. He's not extremely ambitious, so he would request a little more money, but he wouldn't leave. But he's not a computer guy. So it's very hard for him to learn. But the main goal is to train him to somebody. I want to train somebody that I know is not going to leave. That's the main reason why I'm stuck here. And I don't mind. I mean, I'm going to be in an RV for 2 months working remotely, so it shouldn't be a problem.
Yeah, and I think we're on a path now to finally getting all this network stuff set up. Let's see if I've got anything here. A few more pictures. That's the pasteurizer room. So this is one that got an upgrade, right? There's a little bit of andon kind of information here. There are new PLCs in here. There's the paper chart recorders I was telling you about. So we aren't gathering information from these yet, but we could. We could put these on the network and we could say, okay, let's get a electronic version of the chart recorders. Now I asked, why don't you just do everything electronically, right? It turns out there's some kind of laws related to beverage making, right? One of them is you need those circular pieces of paper for certain kinds of reporting. So they're also going through some other certifications to be able to work with people like, the Walmarts and the Aldis and Targets of the world. You have to have certain kinds of certifications, and those may include things like that. Do we need paper records? Do we need electronic records, right? Maybe we need both, right? In a lot of cases, you need both of them. So the goal ultimately is to have even these guys on that same network. But you saw kind of how that thing, we've got that 58 network kind of already filling up full of addresses. And at some point, we're going to end up, we learned a lot about routers this week. Okay, so we kind of, even though he has routers in this plant, but we never tried to use them for this purpose, like having duplicate IP addresses, right, in the network and being able to kind of subdivide those out. I think we're well on our way. Literally by the end of today, we should have one of the palletizers through the router connected up to this. And then we're going to find out, because we're going to stick the other palletizer and it's got the same IP address on it, right? So that's two more things we'll have on this network. At the least, we'll be able to program them. At the most, we'll be able to start adding those tags into Ignition. And the palletizers, like I said, are the tail end of the process. So let's see here. Again, there's some of the piping, old drawings. Hey, here's a picture of my wife was here wiring panels. So she built this was the control panel that went to the compact logics, right? Which has since been replaced with the control logics. So she was really good at wiring. She wired for 20 or more years, very painstaking and everything, but she's kind of retired now. So we don't call her out here to do more wiring. And plus, Umberto is pretty good at wiring. More pictures. There's the finished panel, right? So there's the compact logics, which is, once again, all the stuff's there, but it's migrated. We have now control logics, and I'm not even sure the control logics is here. It's probably where the SLIC was.
The control logics is on the SLIC.
Yeah, so it's where the SLIC was. It's in the cabinet next to it. So things migrated, right? We had SLIC alone, and then we had SLIC with compact logics mapping to Ethernet, and then we went, got rid of the compact logics and migrated to control logics, and then moved all the SLIC code into the control logics. So now there's no SLIC anymore. So that was how you do this while you're running, right? So people want to know, how do you, when you're an integrator, how can you work on a system where you have to do production? Well, very carefully, right? You do a little piece at a time, migrating a little part of it at once, like the palletizers. We've added a couple encoders to them. We're going to make modifications to that. But as soon as he gets the router connected up to it, gee, wouldn't it be nice to make that modification from here, right? I'm sitting at a desk that's in a different building. The building's over across the parking lot. I could connect to that palletizer and watch it and make some online edits. And again, when you're doing integration, the number one rule of integration, probably number one, is don't make everything reversible. Two, write pseudocode in parallel with the real code. Watch the numbers, make sure that in the pseudocode, the numbers are doing what you want them to do, and then go and scab them on into the real program, right? And then clean up your mess, because there will be a mess when you're done. So I did some of that. I actually did the code ahead of time, and it's kind of ready to test, but it would be nice, right, for me to sit here and watch them moving the two little elevators up and down, and I can see, hey, when it hits this sensor, I'm going to reset that number to, I forget what it is now, but I have it written down somewhere in my Excel spreadsheet. It's going to reset it to minus 1500 or whatever the heck it is. And every time it does that, I need it to rehome, basically automatically rehome the system, which is a common thing to do in integration. But I definitely wouldn't want to do that on a running machine and just wing it and hope that it works, right? And the other thing is, you can't download, as I mentioned on the previous thing with the tanks, right? Here I've got this node. It is communicating now, but it's the wrong revision number. Plus, when you add a node to Allen Bradley, the first thing Allen Bradley does is it goes in and it downloads the hardware configuration to that device. So I'm looking at the device and it says, I see card 1, I don't see card 2 and card 3. And I was like, well, are they physically disconnected or is there something else wrong? No, the PLC hasn't told the little .0 IO module yet what its configuration is. To do that, we have to be offline. So I'll have to make that change and do a download.
Okay.
When can you do that? You can do it
Okay.
when the machine is not running. If I do a download, that's the thing for everybody to remember, right? Doesn't matter whose you have. If you're doing a formal download, everything's going to stop, right? So first thing you do, save the program as it exists. Hopefully it's everything still, because if it's not still, if it was moving and I go offline and then I download it and it was moving and the e-stop's not been hit or anything, it's going to start moving. It's going to start moving exactly the way that it was before. So most people at the very least will just e-stop the system, and the system finds out, oh, I'm e-stopped. I need to reset all these parameters anyway, and then you do a normal startup, right? In this case, Sunday is going to be the day because I know they're not running the syrup on Sunday. So, and the palletizers probably are going to be available too. Now, if we get this all communicating today, I can also go online with the palletizers while they're running another time, make my modifications, watch it, make sure the numbers are right, and then make the numbers active, right, on a running system. So that's another one of those integrator things. Like I said, everybody's been asking for integrator device, and that's advice, and that is probably the things I would say. Number one, make everything reversible. Two, if you're working on a running machine, write fake stuff over here. Make sure all the fake stuff works, and then make the fake stuff the real stuff. That's probably the safest thing to do. So this is the blower. This is one of the things that we talk about, that this is an S7-400, which this is the only S7-400 I have ever worked on. I have some programs from some other ones, but this is the only one I've dealt with. S7-400 is a big, bad PLC from Siemens. It's like the PLC 5 was for Allen Bradley. It was their monster. Now they've kind of migrated to everything's in control logics, but it is the bad boy. Let's see what else we got here. Here's another picture of the inside of the blower. The blower, it blows bottles. So it takes little plastic pieces about that big, and it blows them up into big bottles, you know, about that big. They design their own bottles here. I don't know if Juan Pablo does that himself or if that's a Luis thing or whatever, but they actually design that. And there was Humberto. He was the guy we were talking good about. He's a genius, right? He's an electronic genius. The guy can take a board and have no schematics and get an oscilloscope and meter and everything and repair that board. Amazing, right? And I'm an electrical engineer. I can't do that. I even worked in the board level stuff for a long time. I can't do that. But he's from Cuba, and in Cuba they're used to repairing things with duct tape and leftover parts from TVs and whatever you got, right? So he can make anything work. He's kind of a genius there. This is one of the mechanical things that people like Guillermo, the maintenance manager, may be able to work on this, or there's I think Leo or some of those guys are experts in this mechanically. So again, you start teach, they already know all this, and then you add PLC programming to their skill set. They can probably go contract to all the bottling companies in the world and go do very well. So,
and I will lose them.
So this is the bottles after they come out of the line. I have here's a good overhead view. So this is an overhead view of the bottles. They come out of the blower over here, and they head up here, and they go around the top, and then they come down here, and they go through here, and it's like a big intestinal tract. That's the best way to look at it. Big intestinal tract goes through a labeler, checks the labels, right, and kicks off bottles, things like that. Then goes into another room, which I don't have a picture of the other room, but the filler actually fills the bottles at a pretty high speed, right? So you got to be an expert on the filler. Comes out of that room and back into this room, and this is another one of our projects. So this is really worth talking about. This right now is an old computer with a Siemens board in it. Okay, it's not even a PLC. It's an old Siemens controller. Siemens PC controller. It's basically cam operated, and so there are a bunch of drives in here, servo drives, and they are Leroy Summers drives. Now, if you haven't heard of Leroy Summers, it turns out they're basically the same thing as Control Techniques. Control Techniques bought Leroy Summers a while ago, and Control Techniques are pretty popular drives. I think they're owned by Emerson or something now, so servos. But it turned out, right, we had a little documentation on this machine, but this is a probably 1980s, 1990s era machine run by a computer. It's got a PC monitor on it and a little board level controller down in the bottom, and then it's linked over to these drives. So we didn't know exactly how this thing worked, but we said, you know what? If this dies, we can't get new parts for this, right? Not easily anyway. And we really don't even have copies of the program. We have like pieces of the program, but there's a lot of almost looks like basic code, right? So you take the basic code apart and you try to figure out what it does. And our first decision was, hey, it's Siemens. Let's just put another Siemens PLC in there and control some servos, but let the PLC do all the camming and do it modern motion control method. But then it was kind of like, well, if we're going to do that, we're going to be in a world of servos with Step 7, 300, which is certainly a solid world to be in. But we don't know as much about that, as at least I don't, as I do about Allen Bradley servos and using Ethernet IP. And since everything else, not everything in the plant, but a lot of the rest of the plant is Allen Bradley, our latest decision has kind of been, let's put a control-logix in here, let's use Ethernet IP. But here are the gotchas. One, this runs all the time, right? They're not all the time, but they're doing production on this a lot. So we can't like say, let's take this 2 months and take this thing out of service and work on it. That's not going to happen, right? Can't take it out of service for 2 months. So, okay, how can we do this while it's running? Interesting. Well, you would build a parallel panel and you'd put your control-logix in there and you'd put your drives in there. But then we need to duplicate all the cam profiles of this stuff. Now, a lot of this, we just sat here and watched it. And we've looked at the programs that are in the servos, and we kind of have a good idea what it does. The tricky part, this mechanism here runs pretty much constantly. It moves the bottles through the line, right? It's a constant speed thing. But there is another little set of bars that actually flips up over this. I actually do have a video of this somewhere, but it flips up over it and it wraps the film around the top of the bottles, right? And slows down. So there's a cam profile. That cam profile follows the other servo. So that's what, there are 3 servos in there and they're working together and only one of them is the critical cam profile. So can we kind of build this in parallel and just, watch this thing and say, we'll run this servo at a constant thing, and when it hits this point and we trigger it, it goes and makes this quick cam profile on this other thing. We can probably do that. But there's an existing motor we'd kind of like to use. We have to couple all those motors with the existing hardware. So how do you do that? You have to make sure that all the things fit, and they won't because they're Siemens. They're not even Siemens motors. I don't remember. They're kind of a mixture of servos. Do you remember what they are, Juan?
The old motors, they are the I think few.
Oh, SEW Eurodrive motors. Yes, SEW Eurodrive motors. So trying to couple an Allen Bradley motor to a SEW Eurodrive gearbox or whatever might be a tough thing to do. So we're fighting with some of this. And then meanwhile, also, like I said, Juan's going on vacation. So I would say getting all the PLCs up and running so he can go online from anywhere in the country is another important thing. Or I can, right? At least one of us will be available. So this is another one. It's hard to see the fillers, but the fillers are in there. Go through the pasteurizers, there's more stuff. So we don't have connections to any of these PLCs. You can see they're all Allen Bradleys. All right, Panel View Plus, there's control-logix in some of these things. So we know all this. We know what their addresses are, whatever, and we plan on picking up information. This is kind of, these are some of the big pumps, actually, water pumps, I believe, from outside. The one I really wanted to show you was the Monster compressor, but, oh, here it is. There you go. That is a, I don't know, 100 and something.
350 kilowatts.
350 kilowatt motor. It's loud. If you go into this room and this thing's running and some of the PLCs are in here, so poor old Juan Pablo has to go in and program some of the compressors over here in this corner. And when he does that, I may come in and visit him, but when this thing turns off or turns on, I go outside and I stand in the hall. And so hopefully he's wearing something like these headphones to keep him protected from that. In any case, yeah, I didn't realize we're having so much fun. We're kind of out of time. I hope this has been somewhat informative. By the way, this is the thing that purifies the water. That's another thing that's important. So they make juice here, box juice, right? I think you saw some pictures of that. I don't know if there's pictures of the actual boxes. Yeah, maybe not. And they make PET bottles of juice, big bottles, little bottles, all different sizes. So that's all the stuff that we're going to gather information on. There's some boxes. You can see them moving here in the background. So these are little juice boxes, right? Stick straws on the side of them. All this machinery does that automatically. And obviously, a lot of what we're doing in the SCADA system is gathering information from it. I think the reason I put some of this stuff in here later is I said, well, there's a point at which we would need to gather information from that too. For instance, how many hours does that giant compressor have on it? How long has it been running, right? When it gets to, you know, I don't know, 15,000 hours, I would think you need to replace part of maybe the bearings or something. Anyway, nice information to know, because if that thing goes down, and I think they are replacing this, they're in the process of getting something new to replace this big monster here. If this goes down, you're dead. What this does is this provides the air that blows the bottles. So completely different room, but when you're blowing bottles, this goes all the way over to that bottle blower and provides a lot of air at much higher pressure than the regular plant air system. So there are other compressors in here too for regular plant air, but this guy is the blower thing. If this doesn't run, the blower doesn't run. If the blower doesn't run, no water. You're only making boxes. So that would be a bad thing. But that's pretty much that. Of course, a lot of this we covered in the last webinar, which was, I think, December. Juan and I were on another call, and we talked about some of this same system. But of course, since then, we've kind of got into this ignition thing. Juan mentioned that he has a chance to either upgrade ignition, which is going to cost, I don't know, 65% of a new ignition package, or buy a different software package that's maybe closer to half the price, but you don't want to reinvent the wheel. So is it going to be better to upgrade to the new ignition or use this in parallel with it to do some of the reports and things that he wants to do, and then learn both, you know? So one of the things I learned from Juan this trip is he does a lot of Python scripting and SQL scripting. So I got to go in and I'm looking at some of the ignition Python code. I understand a little bit of it, but I don't make modifications like he does. So in the 5 or 6 years that he's been doing ignition now, he's gotten so far ahead of me in the hard coding world, right? The scripting, the structured text, that kind of world, and especially the SQL world. I've messed with SQL, but he's gone way beyond wherever I was on this. So we're learning from each other at this point. Before, it was just me showing him PLC stuff, and now he's got to show me all the all the scripting stuff in ignition. But next webinar is April 2nd. Phil, you may recognize some of these guys, Vlad Romanov and Dave Griffith. They run a webinar called the Manufacturing Hub. And they talk about whatever. I think they had a president of a integration company that does some, repairs, I think, of reconditioning of machines. And then Vlad runs a Solus PLC, which is just PLC classes, I think, online. He's been doing that for a long time. So it's not really I don't think a membership site. It's just you take classes from there, right? Take PLC classes. In any case, I wanted to talk to them about integration and things. And of course, we do this every 2 weeks, no matter what, as part of the Automation Academy. And I post these on YouTube. And of course, I hope that people join the Automation Academy but these are going to be free for the foreseeable future, and people have been joining. I've got several new members lately, surprise, even though I don't probably push it as hard as I should. One of the dilemmas I've got, and for those of you, Phil, I know you're a member of the Automation Academy. I have a guy who's asked me to do some things that involve more than one PLC platform. They want to know indirect addressing on the old RS Logix 500 and how it compares to the Step 7. My dilemma is, where do I put it? Do I put it in RS Logix 500? Do I put it in Step 7? It's not a standard class. So it's more of a, I guess, a lecture on indirect addressing on multiple platforms. If I have to do indirect addressing on control Logix, it's really easy, right? I just use an array pointer and I just point and I say, move that and move it over here. That's not the way it works on the older stuff. So he's asked me to do that. And I said, sure, I'll do that. Where do I put it? So for those of you who are members of the Automation Academy, which Juan Pablo is, he had some comments. He said, it's hard for me to find courses, right? There's a list of courses in here, but there's a lot of stuff on here. How do I know what's in what? I said, well, I don't really have an answer for all that yet, but here a guy wants to add something that involves 2 different platforms. Where do I put it? I think what I've decided to do is I'm going to put an in-between webinar, and I may start doing this regularly. And that webinar, if I finish it by this next Friday, I'll just post it. That will only be in the Automation Academy because it is going to be technical and very valuable information. So I try to keep the very technical and very valuable stuff there because that's why I created a membership site, right? And then this stuff, hopefully everybody learns something from it, right? Talking to Juan, and he didn't get into the down and dirty of how does Python scripting work. Actually, it's Jython scripting, right? How does all that work? But we did hopefully provide some good information. That's one of the things people have asked for is, you know, we want to know how you do what you do. How do you get into these machines and actually make them go? Any comments, Phil?
No, the only comment I had was it'd be fun to have like a glass pipe or something to where you could see the fluid change, maybe put some food coloring in it when the switchover occurs from the tanks.
Oh, yeah, it's the same juice.
Yeah,
right?
it's like, yeah, juice.
So it'll be,
juice.
if it's apple juice, it'll switch over.
It's going to be
another
similar
tank.
color. You're not going to be able to tell.
No, you won't be able to tell. As a matter of fact, they have a guy in here who wears a funny hat because he's from Israel originally or whatever. And he comes in to make sure that you didn't mix juices. That's a non-kosher thing to do.
Kosher thing.
Yeah, so he makes sure that you did your CIP and you cleaned everything out. If you were running grape juice, I don't know what the exact rule is, but there's something about grape juice getting in with other juice. You don't do that. So
interesting. The other thing is I'd imagine with like pharmaceuticals, they probably have a hard stop and then run some type of cleaner through and then resume.
Which is what we do.
Afterwards.
That's what these CIPs are. So when I talked about the CIP we did, this is the fun picture from before. We'll close on this picture. Where's the CIP picture? Oh, actually, it's still over here.
Yeah, so our main problem is not when switching juices that are the different flavor. It's a problem when they're the same flavor. And when they're different flavor, they have to shut down, like you said, and we do a CIP, like a half-hour clean on the tank, and then with that, with some code that Frank already put on the system, it closes automatically. It just closes, and if it's empty for a period of time, but it's a matter of we haven't had what we need to do is just go there in the zero room for 2 days straight and see the error, because the things that are errors for us, the operators sometimes say, no, I mean, they had a system that it didn't do that for 10 years. So now when it doesn't do it for X time, they're like, no, it's okay. They don't tell you the error. We need to know immediately. We need to know the second, because that's how we need to track it and fix it.
Yeah. So this is a CIP machine. This is a fun one. This was the project we did last May, and he had an old CIP that had a GE controller on it. We stripped everything out of it. We put an Allen Bradley controller in it, and we made it run on these 2 fillers. That's the side of the filler in here. And I took this picture because I thought that the all the social distancing stuff in May, that was still pretty unique, right? Last year. But now this thing's been running. So we came in, wrote our own, not proprietary, but definitely our own code from scratch on this. This was going to be an Umberto project. And I think Umberto actually started on it, but he's the genius with the board level stuff, right? I think it got beyond him pretty quick. And then when we finished it, we realized, oh, there was a lot more to this than we thought. There's a lot of recipe stuff, and you pump caustic material for a certain period of time, and then you put acid in there, and you run that for a certain period of time, then you put alkali in there, and you run that for a certain period of time, and every once in a while. So we made recipes where you would actually say, I want to run this first, then this second, and then run this again, right? And then take a break and run just hot water. And so we built like a 10-step thing where you can put recipes and say how much of this, and you actually test the pH. So we do all that for cleaning. And this is just a small version of a giant system that already exists. So the existing system, the problem is you can only clean one thing at a time with it. So you'd have to wait, right? And then clean the other thing and remove all the pipes and all this. This thing, we can run this in parallel with the other one. So it speeded up the CIP quite a bit. And we'll kind of leave it on that note. That's kind of the end of this webinar. And again, in 2 weeks, we'll do it again. And if you're not already a member of the Automation Academy, I would encourage you to join if you get a chance. Like I said, we're getting other folks that are joining. And after I get back to Nashville, I'll be creating lots more content. And that indirect addressing thing's coming soon. I think it's just going to be a webinar. Like I said, I'll do it as if it's live and prepare everything ahead of time, and he'll get an hour worth of material. For people that join, they ask me to do special things like that. I will certainly do that. You know, if people have a good topic and I can figure out where to put it, that's kind of part of why I do this. So it's been fun, guys. Kevin, I haven't heard from you, but you're there. I can see a giant K on our screen. Cool. And Phil, as usual, Phil was our first guest, right? He was a member of the Automation Academy and the first guest on the first webinar back in November 19th or so. And since then, we've had a bunch more, and it's been a lot of fun. Thank you very much, Phil. Thank you very much, Juan Pablo. We're getting back to work. We are going to go stick that router on the PLC, and hopefully I can see it from here. And that's the next step.
Sounds
So, see you guys later.
Thank you.
Thanks.
Thank you.